Hi, this is Alex from devstories.eu, GeoDjango and PostGIS, episode 5 of 15. You want to add location data to your application, so you might think about adding two simple float fields for latitude and longitude to your database, but doing that completely locks you out of advanced spatial queries, distance calculations, and geometric intersections. To unlock those capabilities, you need proper spatial types, which brings us to designing geographic models. Moving from standard Django to GeoDjango models requires only a slight shift in your imports. Instead of pulling from the standard Django database models, you import models from the Geographic contrib module. This custom module provides a drop-in replacement. It gives you access to every standard Django field type, like characters and integers, while seamlessly introducing spatial types into the exact same class definition. Take a scenario where you are building a world border model to store country data. You define the model class just like any other. You assign a character field for the country name, an integer field for the population, and a float field for the total land area. To handle the actual map geometry, you add a geographic field directly alongside the others. For a country, you would use a multi-polygon field. While a point field is perfect for storing a single pair of coordinates like a capital city, a multi-polygon field can represent complex national boundaries, including nations with multiple disconnected landmasses or offshore islands. When you attach this spatial field to your model, you're defining a coordinate system behind the scenes. Every geographic field relies on a spatial reference system identifier, known as the SRID. The SRID tells the database how to project the raw coordinate numbers onto the actual shape of the Earth. If you do not explicitly set this value, GeoDjango automatically defaults the SRID to 4326. That specific integer refers to the WGS84 standard, which is the exact same coordinate system used by standard GPS hardware. If your source data relies on a different local projection, you simply pass the target integer to the SRID parameter right inside the field definition. This is where it gets interesting. Developers familiar with the Django ORM know that to make a column fast to query, you must explicitly pass a database index flag to the field definition. Because spatial queries are inherently heavy, you might assume you need to manually configure specialized indexes for your geometry columns. You do not. Geographic fields in GeoDjango operate differently. They include a specific parameter for spatial indexing, and it defaults to true. When you run your migrations, GeoDjango automatically tells the underlying database to build a specialized spatial index. You get high-performance bounding box queries and geographic intersection lookups straight out of the box, with zero extra configuration. The true strength of designing models this way is that it completely demystifies spatial data. A massive, complex polygon representing a continent becomes just another property on your Python object, ready to be saved and queried alongside a simple population count. That's it for today. Thanks for listening. Go build something cool.